Welcome to Math 8. Today we're on Unit 4, Lesson 6, Strategic Solving. We are going to learn to solve some linear equations like a boss. What we're after with this first one is talking about, here's a situation where we have a little bit of geometry mixed in. The goal is to find the value of x, and then we also need to figure out the perimeter of each figure. So what we need to think about with this for a minute is that this right here is the triangle and the square have equal perimeters. That's kind of a big deal, because if they have equal perimeters, then that tells us that when we think about the perimeter, the P, the capital P here, and the capital P here, those perimeters are equal to each other, which means we can set up an equation to be able to solve what's going on here, or to solve for the x so we can actually find the perimeters. So here we go. Perimeter is the total distance around the figure. So in this perimeter here, we have 2 times x plus 2 times x plus x minus 8 for the triangle. And then on the square, what we know about it, even though there's only one measurement on one side, we know that all 4 measurements are exact same. So we can say that this square has 4 sides that have a measurement of x plus 2. And now from here, it's a matter of simplifying, solving for x, and then we can determine the perimeter. So let's find the value of x. First thing we want to do is combine like terms. You may have heard me talking about combining like terms or collecting like terms. When we talk about like terms, each of these individual values, such as 2x, 2x, x, and 8, these are all terms, meaning that they are an individual value. This term, 2 times x, and 2 times x, and x all have the exact same variable part, which means that they are all the product of a number that has been multiplied by x. 8 does not have that, so 8 is not a like term. You'll notice each of these, there's no exponent written, but we know that exponent of 1 is the expressed value, or is the unexpressed value, I guess I could say. And so what we need to do is we actually need to combine just these 3 of them together to simplify the equation. So we have 2 times x plus 2 times x plus x, that's a total of 5 times x minus 8. And over here on the right, talk quite a bit about this distributive property, where what we're doing is we are going to take the 4 times the x, and we're going to add that to, again, 4 times the 2. Go ahead and simplify those. I think what I'm going to go ahead and do over here is I'm going to show you something just a little bit different. We're going to say this is all of our x's together, and then the 8 is separated, the minus 8 is separated because they're not like terms. So as we simplify that, that gives us 5 times x minus 8 is equal to 4 times x plus 8. As we get going into the next step, we'll just go ahead and start here on the left side. I'm going to add 8 to this side over here to eliminate the 8 from the equation, and we'll go ahead and add 8 to this side over here to the right side because we have to keep equality. This is what we call the addition property of equality. We have eliminated the 8 from the expression on the left. By adding 8 to it, we have added 8 to our expression on the right. To make sure we have equality, we want to subtract the 4 times x because we don't want, where our whole goal is to get x by itself, is what you'll commonly hear. And to do that, we don't want our terms with a variable mixed with our terms with a coefficient. So we will eliminate the 4x. Remember, we can just simply subtract 4x, or we can add the opposite, which is adding negative 4x. So plus negative 4x. And 5 times x plus negative 4 times x is just simply 1x is equal to 16. I should fill this in and check to see if I'm right. How do I check to see if I'm right? Well, through substitution. Let's just double check that substitution quickly. And it looks like my calculator is not going to work for me. So we'll go to plan B. We're going to take all of these pieces right here, where we know that there's twice the value of x, twice the value of 16 is 32. So we're going to do 32 plus 32 plus 16. You can almost do this mentally. And then subtract 8 to equal 72. So just a little note for myself to keep track and saying that the perimeter around here is 72. And then let's go and talk about the perimeter over here on the right side, the square. We have 16 plus 2, which is 18, and 18 times 4 is 72. So we see that the perimeters are the exact same. So I know that 16 is my value for x. And here's the other cool thing. I already found the perimeter. By substituting that value for x right here, to find the perimeter, we would have 2 times 16 plus 2 times 16 plus 16 minus 8. And then over here, I would have 4 times 16 plus 2, which equals 72, 72. And then the perimeter of each figure is 72 units. Kind of cool that we can actually answer a lot more than we probably thought we did just by doing the work that we know we need to do of solving the equation and then verifying that it's right. Next section, we're going to talk about predicting solutions without solving. You read that right. Without solving, identify whether these equations have a solution that is positive, negative, or zero. Taking a look at these values, here's a couple of just quick examples to think about on a very simple term. If I have 5 times x and I have 6 times x and I want to be able to figure out what that value is, all I would have to do with this is I would subtract one value from the other one. So I would subtract 5 times x and subtract 5 times x. And what I'm left with is a 0 is equal to x. By eliminating one of these, when I look at one expression as it comes through, if I eliminate one whole expression from one whole side and that entire expression simplifies to 0, I know that my solution for right here is going to be 0. There's another thought right here. If I have 5 times x is equal to a negative coefficient, I know that dividing a negative by a positive is going to be a negative number, so I know my solution here is going to be negative. Likewise, if I had just two positive numbers on both sides, I'm going to get a positive outcome. So let's take a look at these right here and make some decisions. When I look at these two expressions, talking about number 1, I have a number divided by 6 is equal to 3/4 of a number, or 3 times a number divided by 4. Question is, will this one be equal to a positive, a negative, or a 0? Take a moment to think for a second. I could do a little bit of work to be able to figure out how this one's going to be set up. Please don't think that you're stuck just looking at it and guessing and saying, I don't know, because that doesn't work. Maybe what we'll do is we'll skip one, we'll come back to it, see some other examples, and then see if you can catch on with those pieces. Let's just look at number 2. I think number 2 is pretty easy. If I divide by 7 on both sides, that's going to be a positive divided by a positive. I know that positive divided by a positive is a positive. So this one we know is positive. And we would say positive divided by, I'm going to use the symbols. Positive divided by positive equals positive. Okay. Looks like number 3, it's basically the same thing. It's only this number is 10 times bigger. So I could say the exact same thing. I have a positive outcome because a positive divided by a positive equals a positive. Let's take a look at the next one. Number 4. I see that my constants have the exact same values. I have 11 here and 11 here. And what happens when I subtract 11 from both sides, whoops, I'm getting too excited, I'm writing my number that I want next, is both of them are eliminated. By eliminating both, I would understand that my solution here must be equal to 0. And then my reasoning is because this, subtracting 11 from both sides eliminates constants. By eliminating constants, I have a 0 solution, kind of like right up here on the top. There were no constants up there to be able to figure out. So that's one that that we can go ahead and work with. How about right here? Take a look at this one. I see that I have a negative coefficient here and two positive positive constants. My gut tells me, hey, maybe this one's going to be negative, but there's one more thing I have to consider. If I subtract this 9 from here and subtract the 9 from here, that gives me negative 4 times x is equal to a negative 5. So while I might have initially thought that this is going to be a negative outcome, what I know now is there's a negative divided by a negative, which actually equals a positive. And so I know this is a positive solution. And because it's a negative divided by a negative equals positive. Okay. Next one. Looking kind of the similar type of thing. If I have the positive 5 for my coefficient of x, and I have these other two constants, I think just taking a look at a quick step right here, even adding 8, we have 5 times x is equal to negative 12. I have a positive coefficient and a negative constant. And what I know about this is when I take a negative divided by a positive, my result is a negative. So this one would give us a negative outcome or a negative solution. Next one. Oh man, there's a fraction in this one. That's not very much fun. I want you to think about the nature of that fraction, because this right here is just the exact same equation as this one, only it's going to be multiplied by a negative half over here. What I would suggest from this is very first thing would just be simplify what's shown over here. A negative times a negative is a positive, and a negative times a positive is a negative. And then from there, what we're looking at is when I subtract that 4, I'm left with a negative constant and a negative coefficient. And as we saw earlier, that one must be positive because it's a negative divided by a negative, which equals a positive at the very end. Okay, so now we have to go back and face that one really didn't like of that fraction. What do I do? When I look at that fraction, I need to go back using all those different things that I thought about and thinking about the terms that I was up against. And I want to think about two things. I have what I saw in here. I have a variable on the left and I have a variable on the right. So what happened when we have only variables on the left and only on the right? We saw that happen right here where we just had a variable in 0. We didn't see that anywhere else. So what happens there? What we have to consider with this is there's only x terms. There are no constant terms for the variable to equal. So with this, the constant term is already equal to 0. So with this one, what I know, the solution would come out to 0. And my reasoning is because there are only x terms. And then constant is equal to 0. So we get into a situation just like this. Not quite as tough as what you'd think, but something that after seeing all the other ones, what we see with all these other ones is we see a coefficient and a constant, coefficient with constants, but those constants eliminate each other, making a 0, leaving us with just an x term. These ones we have coefficients and constants, coefficients and constants. We need to consider that we have all of those pieces to be able to work with them. All right. The next one, here's a lot of questions, a lot of equations. As we look at these, I know I haven't shown them to you, but just don't panic. There's a lot of equations. Looking at these, what we need to look at on these problems and what we need to decide is this. Here's a lot of equations. Without solving, identify 3 equations that you think would be least difficult to solve and 3 equations you would think would be most difficult to solve. Be prepared to explain your reasoning. My experience has taught me that most people will be afraid of ones that have fractions like these. That these ones would be the most difficult equations to solve. And that the ones that would be the easiest would be ones that tend to be like this, just a binomial times something smaller, that those would be the ones that are a little bit simpler. What I would like for what you are going to do today is you have to choose 3 of them to solve. At least one should be least difficult and one should be most difficult, and you pick the third. I am expecting to see these as part of your assignment. You'll need to take a picture of them, solve them on a piece of paper, and then send me a picture of them so that you can prove to me that you did these. So that's going to be a part of your homework today. Choose 3. And that's what you're going to spend the remainder of your time doing for classwork today. You do have a little bit of homework, but remember that what you're after with these, just 3, one that's simple, one that's difficult, and one that's your choice, another simple or another difficult one. But I need to see them, and I know that you're probably frustrated that I'm not showing you how to do it, but I want you to give it a shot. Don't forget to verify that your answer is true to know if you got it right. Take your time. Make sure that you are going at a somewhat of a simple pace or a steady pace with this. I'm going to identify the ones that I think are difficult just based on what people typically tell me. These ones are typically the ones that people identify as difficult. You may say that they're all difficult, but I would say that this is traditionally what I see. And I know I keep repeating myself, but that's because that's where I'm at. So 5 of them would be considered difficult, in my opinion. 5 of them are not. These are what you need to choose from. You need to choose one of them that I've identified as difficult and one that I've identified as easy, and then pick your own and solve. Make sure you check what's going on. Here's your recap for the lesson. Sometimes we're asked to solve equations with a lot of things going on each side. For example, here's an equation here with an expression that has distributive property and such, and here's one with distributive property and division. It has variables on each side, parentheses, and even fractions to think about, but before we start, we need to take a closer look at the fraction on each side, on the right side, than that expression. And we need to understand that it's just being multiplied by 3. And how could we simplify that? Maybe we could just make smaller numbers by taking 3 divided by 6 and making that a half. And that would make our expression look like 2 times x minus 20 divided by 2. And even from there, I could divide those by 2 because 2x divided by 2 is 1x and 20 divided by 2 is 10. And so what we see is that an equation that starts out super difficult might not be as difficult as we really think after we've done just a little bit of simplifying. We can do some distribution from this point, collect some like terms from each side, and then we have a little bit less even after that to look like this. We go down to an equation that's down to 2 times the sum of x and 5, and then from here it gets pretty simple as well. We distribute and we find out x plus 5 just by dividing by 2 on both sides. Divide that 2 off and that 2 off, and then we get x plus 5 equals x plus 5, and we find out x is actually equal to 0. All of that work, it's not positive, it's not negative, all of that work, and we find out that x is equal to 0. That doesn't mean that every difficult equation like this is going to be equal to 0, but it does mean that you can't discount how easy a question can be just by looking at it. So give it your best. Remember, you must choose 3. One easy, one difficult, one of your choice. Make sure you're ready to attach it. Hope you have a great day.